The heat death. Picture the last star in the universe guttering out like a candle in a sealed room. No explosion, no drama, just light, fading. Scientists call this the heat death, and it is the most likely ending for everything that exists. The mechanism is thermodynamics. The second law says entropy always increases. Order breaks down. Energy spreads out until it is perfectly, uselessly uniform. No temperature differences means no work can be done. No work means no stars, no chemistry, no thought. The timeline is staggering. The last red dwarf burns out around 10 to the 14 years from now. After that, the universe becomes a cold, dark graveyard of stellar corpses. The pivot is this: heat death is not a violent end. It is a slow erasure. No crunch, no rip, just silence, spreading forever. Physicists have no mechanism to escape it. The laws themselves are the enemy pressure, and the transformation is total. Everything that ever existed becomes indistinguishable noise, the Stelliferous Era. Right now, tonight, the universe is in its golden age. Stars are being born, galaxies are colliding and sparking new suns. This era, called the Stelliferous Era, runs from roughly 10 million years after the Big Bang to about 100 trillion years from now. That sounds infinite. It is not. Star formation is already slowing. The raw gas clouds that birth new stars are being used up. The Milky Way forms roughly 1 to 2 new stars per year now, down from dozens per year in its peak. The cost is invisible from inside the era. Everything looks fine, but the fuel supply is finite. The pivot, the universe is already past its most fertile period. Peak star formation happened about 10 billion years ago. We are living in the long afternoon of cosmic history, not the morning. Enemy pressure is simple math. Gas runs out. New stars stop forming. Old ones die. The Stelliferous Era ends not with a bang, but with the last star simply stopping to shine. The Degenerate Era. After the last star dies, something strange is left behind. White dwarfs, neutron stars, and black holes drift through a lightless universe. This phase is called the Degenerate Era, and it lasts from roughly 10 to the 15 years to 10 to the 37 years from now. The white dwarfs cool slowly. They become black dwarfs, objects so cold they emit almost nothing. Neutron stars spin down. The universe becomes a cemetery. But here is the pivot. Some physicists believe protons themselves decay during this era. If proton decay is real, every atom in every dead star eventually dissolves. The solid remnants of suns and planets simply evaporate into radiation over unimaginable timescales. No confirmed detection of proton decay exists yet. The enemy pressure is quantum mechanics itself, slowly dismantling matter from the inside. What survives this era is almost nothing. Just black holes and thin radiation. The transformation is the loss of matter as a category. The black hole era. Imagine a universe with no stars, no planets, no atoms. Just black holes, drifting and occasionally merging. This is the black hole era, spanning from roughly 10 to the 40 years to 10 to the 100 years from now. Black holes become the dominant feature of existence. They occasionally collide, releasing gravitational waves into an otherwise silent cosmos. But even black holes are not permanent. Stephen Hawking predicted in 1974 that black holes slowly leak energy through quantum effects at their event horizons. This is called Hawking radiation. A stellar mass black hole takes 10 to the 67 years to evaporate. A supermassive black hole takes 10 to the 100 years. The pivot, the very objects that seem most permanent, are bleeding away. The enemy pressure is quantum uncertainty at the edge of the event horizon, producing a slow trickle of particles until nothing remains. The collapse is the evaporation of the last black hole, releasing a final burst of gamma radiation into an empty universe. The Big Rip. Not every cosmologist agrees the universe ends quietly. One competing model says it ends violently, and soon by cosmic standards. The Big Rip scenario, formalized by Robert Caldwell and colleagues in 2003, proposes that dark energy is not constant. If dark energy grows stronger over time, it eventually overcomes every force in the universe. Gravity loses. The strong nuclear force loses. Atoms are torn apart from the inside. The timeline in some models puts the big rip roughly 20 billion years from now. Galaxies shred first, then solar systems, then planets, then individual atoms. The final seconds before the rip see the fabric of space-time itself tearing. The pivot, the very force accelerating the universe's expansion today, might be the weapon that destroys it. Enemy pressure is the unknown nature of dark energy. We cannot measure its future behavior with certainty. If the equation of state crosses a specific threshold, the quiet heat-death scenario is replaced by something far more sudden and total. The Big Crunch. Before dark energy was confirmed in 1998, the leading end-of-universe theory ran in reverse. The Big Crunch proposed that gravity would eventually win. Expansion slows, stops, reverses. Galaxies rush back together. The cosmic microwave background heats up. Stars collide. Matter compresses into a single point of infinite density, mirroring the Big Bang but in reverse. This model fell out of favor when observations confirmed accelerating expansion. But it has not been fully buried. Some theoretical frameworks allow for dark energy to weaken over time. If it does, gravity reasserts itself. The pivot, the Big Crunch, is not just an ending. Some physicists proposed it could be a bounce, a new Big Bang emerging from the collapse. This is the cyclic universe idea. Enemy pressure came from the data itself. The 1998 supernova observations by Saul Perlmutter and Brian Schmidt showed expansion accelerating, not decelerating. The crunch model was sidelined, but the underlying question of what dark energy will do remains open: the Boltzmann brain. Here is the strangest consequence of an eternal universe. If the heat death leaves the cosmos in a state of maximum entropy forever, quantum fluctuations still occur. Given infinite time, random fluctuations can spontaneously assemble almost anything, including a conscious mind floating in the void. This is the Boltzmann brain, named after physicist Ludwig Boltzmann. The logic is brutal. If the universe is eternal after heat death, random fluctuations producing a momentary conscious observer are not just possible, but statistically certain over long enough timescales. The pivot. This creates a philosophical crisis. If Boltzmann brains are more likely than evolved conscious beings, then your memories are probably false, assembled by chance moments ago. Physicists treat this as a reductio ad absurdum. Any cosmological model that predicts more Boltzmann brains than real observers is considered broken. Enemy pressure is the math itself. The concept forces cosmologists to take seriously what kinds of observers a universe actually produces and why. The false vacuum. The ground may already be unstable. Physicists discovered that the Higgs field, the field that gives particles mass, appears to sit in a metastable state. This is called the false vacuum. It looks stable. It is not necessarily stable. A quantum fluctuation anywhere in the universe could trigger a phase transition, a bubble of true vacuum expanding outward at the speed of light. Inside the bubble, the laws of physics are different. Atoms cannot form. Life cannot exist. The bubble arrives with no warning because it travels at light speed. You cannot see it coming. The pivot. Measurements of the Higgs boson mass, confirmed at CERN in 2012, put the universe uncomfortably close to the boundary between stable and metastable. Enemy pressure is pure probability across infinite time. The longer the universe exists, the more chances for a fluctuation to trigger the transition. Collapse is instantaneous and total, a rewrite of physical law spreading across all of existence. The Big Freeze variant. Some physicists distinguish a subtler version of heat death called the Big Freeze. Rather than a smooth thermodynamic equilibrium, the Big Freeze focuses on temperature. The universe cools toward absolute zero as it expands. Expansion itself drives the cooling. The cosmic microwave background, currently at 2.7 Kelvin, will drop towards zero over trillions of years. The pivot. Even if proton decay never happens and Hawking radiation is wrong, the universe still freezes. Expansion alone is enough. No energy gradients means no thermodynamic engines. No engines means no complexity. The enemy pressure is the expansion of space itself, stretching everything apart, diluting energy density toward nothing. Stars cannot form in a universe too cold and too diffuse. The Big Freeze is the quiet version of the same ending, a universe not torn apart or collapsed, but simply too cold and empty to do anything at all. Dark energy dominance. 40% of the universe's history has already been controlled by dark energy. Since roughly 5 billion years ago, dark energy has been the dominant force driving cosmic expansion. We do not know what it is. The leading placeholder is the cosmological constant, a term Einstein added to his equations in 1917 and later called his greatest blunder. He was wrong to disown it. Dark energy behaves like a property of space itself, a pressure built into the vacuum. As space expands, more vacuum exists, so more dark energy exists. The expansion accelerates. The pivot, this is a feedback loop with no known off switch. Enemy pressure is our ignorance. Every proposed explanation for dark energy carries different predictions for the universe's fate. If it is truly constant, heat death follows. If it grows, the big rip follows. If it decays, the crunch becomes possible again. The fate of everything hinges on a quantity we cannot yet measure precisely enough to distinguish. The cosmic web collapse. Zoom out far enough, and the universe looks like a web. Filaments of dark matter and gas connect galaxy clusters with vast empty voids between them. This structure is the cosmic web, and it is already changing. Galaxies inside clusters are falling inward. The Milky Way and Andromeda will collide in roughly 4.5 billion years. The local group of galaxies will merge into a single elliptical galaxy. But beyond the local group, expansion wins. Distant galaxy clusters are already moving away faster than light can cross the gap. They will become permanently unreachable. The pivot. The observable universe is shrinking, not growing. Future civilizations, if any exist, will see fewer and fewer galaxies. In roughly 100 billion years, only the merged local group will remain visible. Enemy pressure is the accelerating expansion erasing the evidence of the larger universe. The transformation is isolation. The universe becomes a series of lonely islands, each unable to see the others, each eventually dying alone. The last possible moment. Some physicists ask a different question. Not when does the universe end, but when does the last possible complex event occur? The answer is a number so large it defeats intuition. 10 to the 10 to the 120 years from now, quantum fluctuations could theoretically reassemble a configuration resembling the current observable universe from scratch. This is the Poincaré recurrence time drawn from Henri Poincaré's 1890 work on dynamical systems. Given infinite time, any finite system returns arbitrarily close to its initial state. The pivot. This means endings and beginnings blur at timescales beyond comprehension. Enemy pressure is the question of whether the universe is truly finite or infinite in volume. An infinite universe never recurs. A finite one might. The transformation is conceptual. At these scales, the distinction between a dead universe and a newborn one becomes meaningless, and here is what all of it adds up to. The universe is not heading toward one clean ending. It is heading towards several possible endings at once, each one contingent on measurements we have not yet made. Dark energy, proton decay, vacuum stability, the geometry of space itself. These are the variables. What we know for certain is that the era of stars, planets, and life is a brief window, already past its peak. The universe is not built for permanence. It is built for process. And the most unsettling detail is this: the laws that made complexity possible are the same laws that guarantee its end.